All right, in this video, we're going to look at a car crashing into a wooden wall and into a padded wall, okay? And I want you to see this because next week when we do the crash bumpers, we'll be getting some kind of similar information from our force probes at school. Although I'm not sure it'll look exactly the same, but this is the idea, okay? All right, so the first one is the cart into the wooden wall, okay? Right? And this is a graph of force versus time, all right? And what I want you to see is what we're going to try to look for basically is the maximum force and the time that it takes, okay? So here, we're reading it right here, okay? The max force, so you're going to record this onto your slide, 45.74, and that should be newtons because it's a force, okay? And then the time we're going to use is 0.008 seconds. Okay. All right. And this isn't a perfect analysis, but just for what we're trying to see, this will be good enough. Okay. So we're going to take the maximum force at 45.74 newtons, and that happens at 0.008 seconds. Right. So we're going to assume that that's the time that it takes till it just slows down to a stop, and then it might bounce after that. Okay. All right. So that was for your on the wood. And what I want you to do is draw a force diagram of the cart as it is hitting the wood. Okay, and that's what the force diagram should be. All right, so you can stop and pause it now and do that part if you want, or go back and finish all of it. Okay, so the next trial is the light cart into a padded wall. Okay, right? And again, we are sort of trying to see what happens if we can change the time of the crash. All right, so here I can read the maximum force is 22.34. Okay, so much less than it was the first time. Okay, and the time is about 0.028 seconds. Okay, 0.028 seconds. All right, so the time has increased quite a bit, and therefore the force has decreased quite a bit. Okay, and it's probably not going to be, the ratios are probably not going to be exactly the same. It should be, you know, 1 doubles, 1 half, 1 triples, 1 thirds. Okay, but this analysis isn't perfect. Okay, so we're just kind of looking for general trends of more time, less force is good enough for what we want. Okay, so again, maximum force 22.34 newtons at 0.028 seconds. Okay, and then again, a force diagram, and think about how the force looks differently sized to the one that we did prior on the wooden wall. Okay, so I should see a difference in the size of those normal force arrows coming from the wall. Okay, right? And again, just another reminder that it's not that the padded wall is softer, right? Where it doesn't have anything to do with being softer. What we're really trying to do is we're trying to increase the time that it takes for the crash. Okay, increasing the time of the crash lessens the force of the crash. That's what you should be writing at the bottom. Okay, or the force felt during the crash. Okay, increased time, less force. That's what we're going for.